That low hum from the power lines above your street isn't random. It's a precise, audible fingerprint of electricity itself. Most people walk past power lines without noticing, but if you stop and listen on a quiet day, there it is. A steady, almost musical tone, not loud, not threatening, just there. That sound is telling you something fundamental about how electricity moves through the world. To understand the hum, you need to understand what electricity actually is. It's not a thing you can hold. It's a flow of electrons, charged particles moving through a conductor, and that movement isn't constant. It pulses. In North America, that pulse happens 60 times per second, 60 hertz. In Europe and most of the world, it's 50 hertz. Your wall socket doesn't deliver steady power, it oscillates. Flicks on and off, so fast your lights never seem to flicker. But the electricity knows. So here's the question: how does a pulsing electrical current create a sound? The answer lies in magnetism. Every current generates a magnetic field around it, and when that current oscillates, pulses in and out, the magnetic field pulses too. Power lines are made of metal. Metal conducts electricity. And here's what most people don't know: a changing magnetic field can push on metal. It can actually make it vibrate. 60 times per second, the field strengthens and weakens. 60 times per second, the wire moves just a fraction of a millimeter. That tiny vibration pushes the air around it. The air molecules bump into each other. A sound wave is born. 60 cycles per second means the sound wave has a frequency of 60 hertz. That's a very low note, below the range most of us hear clearly. But some people do hear it, and animals hear it better. But power lines aren't the only thing that hums. Walk past a refrigerator, stand near a microwave, listen to the hum from a transformer box on the street. All of them oscillate at the same frequency. All of them create electromagnetic fields. All of them vibrate. The hum from a refrigerator is actually louder than a power line. Why? Because the equipment inside is denser. More metal, more coils of wire carrying current, more chances for vibration to happen. The electromagnetic field has more to push on. There's another layer to this. Some of that hum isn't vibration at all. Some of it comes from the air itself. When a strong electromagnetic field exists, it can ionize the air, knock electrons loose from air molecules. Those electrons move, they collide, they create a crackling sound almost like tiny lightning. This is why power lines hum louder on humid days. Water in the air conducts electricity better. The ionization is stronger. The crackling is louder. You've probably noticed this without realizing it, that deeper, more persistent hum on damp mornings. Now, what about your appliances? Why does your phone charger hum? Why does your laptop make that faint whine? Same principle, but smaller. The currents are weaker. The magnetic fields are weaker, but they're still pulsing at 60 hertz. Some devices hum at 120 hertz instead. That's because they use a rectifier, a circuit that converts oscillating current to steady current. But the conversion isn't perfect. A ripple remains, and that ripple vibrates at twice the original frequency. Engineers know about this. They call it electromagnetic noise. It's not dangerous at these levels, but it's real, it's measurable, and it's everywhere: every power line, every appliance, every device plugged into your wall. There's something almost poetic about this. The hum is a kind of conversation. Electricity and magnetism talking to each other. The energy flowing through the wires literally sings. We just have to listen. Some people are bothered by the hum. Others find it comforting, a constant reminder that power is flowing, that systems are working. Some can't hear it at all. But whether you perceive it or not, the physics is the same. Oscillating current, pulsing magnetic field, vibrating metal, sound. So the next time you hear that low hum from a power line, a refrigerator, a charger, you'll know what you're hearing. You're hearing the physical manifestation of electricity itself. You're hearing the world's electrical nervous system at work, pulsing, vibrating, humming at exactly 60 cycles per second. That hum you've heard your whole life, it's not background noise, it's the sound of physics. It's the sound of invisible fields pushing on metal. It's the sound of the modern world singing at a frequency we can barely perceive but never fully escape. Subscribe to discover the hidden science behind the everyday sounds and phenomena surrounding you. New physics revelations every week.